Two kids are playing catch when one kid throws the ball and it lands on the roof of his house. He gets a 10 kilogram, 10 meter ladder to retrieve the ball. He weighs 45 kilograms. When the ladder is against the house, there is a 50-degree angle between the ladder and the ground. He gets 3/4 of the way up before the ladder begins to slip. What is the coefficient of friction between the ladder and the ground? Imagine the wall is frictionless. So here we've got our house, the ball, the ladder, the ground, 50 degrees. It's our pivot point right here. Okay, so 10 kilograms, 10 meters. The kid is 3/4 of the way up. He weighs 45 kilograms. He got 3/4 of the way up, so that's 7.5 meters. Okay, now let's fill in our forces. So we have Fg of the ladder. We have Fg of the kid. We have N1. We have FF1. We have N2. And we have FF2. Okay, so let's do our force or not our force now. So let's find the angle of right here first. So we know that this angle is 90. So 90 minus theta equals phi. So that means phi equals 90 minus 50. So phi equals 40 degrees. So now let's do our force analysis. First up is our x direction. So in the x direction we have FF1 and N2, so FF1 minus N2 equals 0. So let's rearrange this. So FF1 equals N2. Now let's break FFF1 down. So FF1 is also equal to mu N1 equals N2. That's as far as we can take it, so let's do our y direction now. In the y direction we have N1, FF2, FGL, and FG kid. So we have N1 plus FF2 minus FGL minus FGK equals 0. Our FF2 is going to cancel out because we said earlier that the wall is frictionless, so that goes to 0. So we're left with N1 minus FGL minus FGK equals 0. So now let's rearrange for N1. So N1 equals FGL plus FGK. Let's break our terms down now. So N1 equals mass of the ladder times gravity plus mass of the kid times gravity. Now let's simplify this equation a bit. So N1 equals gravity, open the bracket, mass of the ladder plus mass of the kid, close the bracket. Okay, so let's fill in and find out what N1 is. So N1 equals 9.81 meters per second squared. Open the bracket. The mass of the ladder is 10 kilograms. 10 kilograms plus the mass of the kid is 45 kilograms. So that would mean N1 equals 539.55 newtons. We'll need that later. Now let's do our torque analysis. So we have torque of N2 plus torque of FF2 plus torque of N1 minus the torque of FF1 minus torque of FGL minus the torque of FGK equals 0. So first up, FF2 will go to 0 because the wall is frictionless, and the torque of N1 and FF1 will go to 0 because our pivot point is there. So that leaves us with the torque of N2 minus the torque of FGL minus the torque of FGKid equals 0. So now let's break each of the terms down. So N2 R N2 sine theta minus FGL RL sine phi minus FGK RK sine phi equals 0. So we're trying to find N2, so we're going to rearrange for N2. So N2 R N2 sine theta equals FGL RL sine phi plus FGK RK sine phi. Now we're going to divide both sides by Rn2 sine theta So now that we have N2 equals FGL RL sine phi plus FGK RK sine phi over Rn2 sine theta. So let's fill our terms in now. So N2 equals FG, which would equal 10 kilograms times 9.81 meters per second squared times 5 meters times the sine of 40 degrees plus 45 kilograms times 9.81 meters per second squared times 7.5 meters times sine of 40 degrees all over 10 meters times the sine of 50 degrees. So N2 equals 10 times 9.81 times 5 times sine 40 equals 315.29 newtons plus 45 times 9.81 times 7.5 times sine 40 equals 2,128.19 newtons over 10 times sine 50 equals 7.66 newtons. So N2 equals 315.29 newtons plus 2,128.19 newtons, all divided by 7.66 newtons equals 318.99 newtons. So now that we have N1 and N2, we can use this equation from before and fill each of those values in to figure out what our mu value is. So rearrange that. That becomes mu equals N2 over N1, which equals N2 is 318.99 newtons. N1 is 539.55 newtons. So that equals, when we put it into the calculator, 318.99 divided by 539.55 equals 0.5912. And that is our answer.